Okay, this is Geometry Section 8.4. It's called Trigonometry. It's on page 596. And we're going to learn trig today. And really, honestly, this is the basis of our class, Trigonometry. But trigonometry is one of the most useful maths in world applications. Kids always say, when are we ever going to use this? Trigonometry actually is very useful. Okay, so the first thing is this is about the only time that I'm going to spell trigonometry. We normally just refer to it as trig, okay? Because it's the only word in mathematics, you don't confuse it with anything, okay? Trigonometry means triangle measure. Triangle measure. The interesting thing about trigonometry is most of it is based on a right triangle, but not all of it. Most of it is based on a right triangle. So there's that much information that we can create a whole new section just based on triangles. Okay? But since we focus on a right triangle, let's draw a right triangle. Okay? Now you got to understand that in a right triangle, we already know about trigonometry. We know one thing. We know two things. We know the special right triangles, and we know the Pythagorean theorem. And you can do a lot with those things. What I'm going to show you today increases what you can also do given less information. Okay? So I'm going to label these like we always do. The two acute angles are called A and B. Across from them are little a and little b. And then the right angle is called big C, and across from it is little c. Right? And this is trigonometry. Okay, so we came up with some ratios. And that's all these are, guys, are ratios. Do you know what a ratio is?
Yes.
It's a fraction, right? It's a fraction. Okay? The first one is we said, all right, if we're going to assign the sine of angle A. And I'm going to choose angle A. I can choose two angles, A or B. I cannot choose C. We can't do these of the right angle. We can only do them of the two acute. Now we write this as sin of angle A. We do not pronounce it as sin. Okay? It is definitely sine, although we just drop the E. It doesn't really help us much, but it's just one abbreviation. And what this is this is the ratio of the opposite leg of angle A, right, over the hypotenuse. Now the hypotenuse is simply the hypotenuse, isn't it? So we don't have to say anything. Okay, so in this case, the opposite leg of A, if we go that way, is little a over C. So it's that ratio, little a over C. Kagan, do you understand? All right. The next word we're going to use is cosine of angle A. And actually, this is all lowercase. You don't want to mess up. And we use cos of angle A. Now, I could do this of which other angle again?
B.
B, but I can't do it of anything else. And this is the adjacent we've talked about.
What does that say next to angle A?
Equals what?
Equals what?
CA?
A over C.
No, that says cosine and then equals.
This is an angle symbol, sorry.
It's COS.
COS, I'm sorry, COS. It's the adjacent leg of angle A over the hypotenuse. So if you look at the adjacent leg of angle A, it's this B. Do you understand the difference between adjacent and opposite? Opposite is across from A, adjacent is right next to it. Adjacent means side by side. It actually helps to form A. And simply people say, well, couldn't you use C? No, C is the hypotenuse. It has its own information, right? So this one is B over C. You understand it? Okay. The last one we're going to talk about, now there's actually three more, but they are reciprocals of this. We're going to talk about the tangent of angle A, which is tan of angle A. Okay? Now the tangent is the only one that does not involve the hypotenuse. Okay? And it is the opposite leg of angle A over the adjacent leg of angle A. So it is actually the opposite, which is A over B. Okay? Now, you have to memorize these. And for a long time I didn't teach this, but I do now, because I found out that students, once I taught it to them, they actually learn this better than what I teach them. And so we came up with this saying. Stands soa katoa. So katoa. Some people just say so. Sometimes I say soa, but it's really so. Okay, it stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Soa katoa. Okay? I have a lot of students that write that at the top of their page before they ever begin an assignment. Okay? So, let's say that I have a right triangle, and I just draw a right triangle here. And I call this P, and this is Q, and this is R. Okay? So, and I'm gonna say this is 15, this is 8, and this is 17. By the way, you can check this because we now know what a Pythagorean triple is, don't we? Okay? And it is a Pythagorean triple. In other words, if I squared this and I added to that squared, it would equal that squared. Okay? So if I say I want the tangent of angle Q, then the tangent of angle Q would be the ratio. I'd go up here to tangent, or tangent is opposite over adjacent. So I look at angle Q, this is angle Q, and I go the opposite, which is 8, over the adjacent. So that ratio is that. Do you understand that?
And it's not over 17 because that's the hypotenuse.
Right. The hypotenuse is not in the tangent ratio. Yes.
If it was like 8 over 16, would you have to
Simplify?
simplify?
Yes.
Okay.
Good question. So if I say the cosine of angle P, what would be the cosine of angle P? Well, cosine is adjacent over hypotenuse. Here's angle P,
8 over 17.
8 over 17. You understand? So we'll do one more. The sine of angle Q. What is it? It is also 8 over 17. Notice these two are the same. They are called cofunctions of each other because they are actually the same. Okay? When you take notice, it's different angles though, right? Different functions, different angles, right? Tangent has a cofunction too, it's cotangent, but we don't talk about that.
So the opposite is the one just directly, like,
What's that?
the opposite, so this is opposite of leg A. So it's
Yeah,
just
the opposite leg. So if I say opposite of P, it's the opposite over the hypotenuse, or the opposite over the adjacent. Okay, so let's say somebody says, well, what is the cosine of 45 degrees? Okay, and you're going, oh, all right, how do you do that? Well, first of all, what do you think you should do? What do I always tell you to do in geometry?
Draw it out.
Draw it out. Very good. Somebody's been paying attention. So this is 45, right? Okay, so I'm just going to take this angle, right? Okay, how big is this? Let's just make up, what's the smallest that this can be? Can it be anything? Can it be 7?
Yeah.
Can it be 8?
Yep.
Okay, but what is the smallest it can be to work with? What would be a great guess?
5?
How about 1?
1. Yeah.
Can we make it 1?
Sure.
If this is 1, what's this one? 1. What's this?
1. It's great.
No.
Square root of 2. Thank you very much. Where'd that guy get that?
1 times 3, 2.
Yeah, you do the Pythagorean theorem, but we also know that a leg, the hypotenuse is equal to a leg times the square root of 2, right? And what's 1 times the square root of 2?
Square root 2.
Right. Could I have this 7, 7, and this 7 square root of 2? Yes, but isn't 1 much easier to work with? Sure. Okay. So the cosine of 45 degrees is, cosine is adjacent, which is 1, over hypotenuse, which is 1 over,
Square root 2.
but we can't leave it like that, can we? We have to rationalize the denominator, correct? And so we get the square root of 2 over
2.
2. All right, now what I want you to do is I want you to do the sine of 60 degrees. The sine of 60 degrees. So the first thing you should do is do what?
Draw a triangle.
Draw a triangle. Label one of the angles 60 degrees. Then the other one has to be
30.
30. Now, we want to choose our lengths. We can choose them anything we want, right? But let's choose the shorter leg. And what should it be? 1. Very good. And if it's 1, what's the hypotenuse? How big is the hypotenuse compared to the shorter leg?
Times 2.
Times 2. So it is
2.
2, and then this is?
LS3. Short leg to the square root of 3.
So it's the square root of 3 times 1, which is the square root of 3, correct?
Yes.
So the sine of 60 degrees is sine. We go to the 60-degree angle, right?
That's it.
It is opposite, which
Square
is
root of 3.
square root of 3 over.
2.
That's correct. See how that works?
What if
Yes.
you put the 60 like down at the other end?
Oh, then,
It's the same.
well, let's do that. I mean, if I put the 60
Oh, that
down
makes
here,
sense. Yeah,
then I still have, this is 1, this is the square root of 3, and this is 2. So it's still going to end up the sine of 60 degrees is square root of 3 over 2. That never fails. All right? Okay. Does that make sense? All right. Well, really what trig helps us to do is it helps us to solve triangles that we don't have an answer for. Okay? All right. For example, let's say that it says find x. Let's go ahead and find x to the nearest, I think the book says 100. Let me double check that. Yep, okay. So let's take, what number am I on? I didn't really number them, so let's do number 1, okay? I'm going to draw my right triangle weird. This is 18, and this is 25 degrees. And I want to know x. Okay, now I told you that the Pythagorean theorem, if we knew two sides, we could find the third, right? And a 30, 60, 90, we could find any sides as long as we were given one of them, right? And same with the 45, 45. But now, look, we're given, this is not a 45, that's 25, by the way. This is not a special right triangle. We can't use the Pythagorean theorem because we don't know any of the sides. So we use trig. All right, so here's what we do. See this Kagan? We have a given angle, right? It's 25 degrees. So we find that given angle. We look where the side that's given and the side we're looking for. All right, let's look at this. The side we're looking for is opposite, right? And then the side that's given is adjacent. Which trig function is an opposite and adjacent?
The last one.
Tangent. So we say the tangent of the angle, which is 25 degrees, equals x over opposite over 18, correct?
Yes.
Now, I'm kind of weird, but I make a proportion out of it. Why? Because to solve a proportion, we just cross multiply. So I put tangent 25 degrees over 1. Is it always over 1? Yes, because that's what, So I cross multiply, and I take 18 times the tangent of 25 degrees equals x. Now, if you take your calculator, okay, you push 18 times the tangent, there's a TAN button, tangent of 25 degrees, and hit equals, it'll tell you how big that side is. And we want it to the nearest 100.
8.39.
That is correct, 8.39. All right? What do you think? Let's take a look at this one. This angle right here is very small. It's 7 degrees. This is a right angle. This is 5 feet. Now we got a label, right? We didn't have a label on this one, and this is y. Okay, first of all, my first question to you is, what trig function am I going to use to solve for y? Sine. Okay, sine. Because I have the opposite leg in the hypotenuse. So I take the sine of what? No, sine of what? 7 degrees. You always take it of the angle equals y over 5, correct? I put it over 1, and I cross multiply. So I take 5 times the sine of 7 degrees equals 1 times y, which is y. So to the nearest tenth, what is y? Or to the nearest hundredth, what is y?
0.60.
One.
Try it again. 5 times the sine of 7?
Yeah, 0.61.
No.
Did you take 5 times the sine of 7?
0.61.
Oh, that's a misprint. 0.61, right? 0.61 feet, right? All right, here's a misprint. Huh. Oh, no it isn't. I just figured it out. Never mind. Okay. All right, now let's take a look at this one. Let's do something a little different. Let's turn the right triangle around. This is 70 degrees up here, 70 degrees. And this is x, and this is 15. What trig function would I use to solve that?
Cos.
It would be cosine. Cosine of what?
70.
70 degrees equals?
15 over.
Okay, now this one's different, right? We're still going to put it over 1. Why is this one different?
Because you're taking x times.
That's right. You're cross multiplying. X is on the bottom, so we have x times the cosine of 70 degrees equals 15. How do I solve for x? How would I solve for x? Divide by cosine of 70 degrees. So we're actually doing division now, aren't we? Okay, so how do I plug this into my calculator? I take 15 divided by cosine 70 equals
43.85.
43 point what?
86.
43.86. All right. Now, all 3 of these problems, we solve for a angle or we solve for a side. Which is it? We solved for a side on each one of these. And every single one of them, we divided by, we either multiplied or divided to solve, right? You all understand it? If I gave you 2 sides, could you figure out what the angle was? And the answer to that is yes. We use a concept of what we call inverse. And it's on your calculator. So we can take the inverse sine, inverse cosine, or the inverse tangent. Guys, on your calculator, I don't know what your calculator is. Does it say sine to the minus 1?
Yeah.
Okay, that's the inverse. Cosine to the minus 1, tangent to the minus 1. Do you understand that? Can I have your eyes? When you solve for an angle, you always do the inverse. When you solve for the side, you just do the normal. So on the inverse, I think you have second, right? Okay, so when we're looking for an angle, you always got to go second. Okay, so let me give you an example. All right, this is number 4. Okay, let's say that we have, this is a right angle, and this is 20, and this is 6, and this is B, and this is A, and this is C. And I want to know what the measure of angle A is. So if I'm looking for an angle, this is an angle, I'm looking for this right here. Okay, now, once I identify what angle I'm looking for, I look and see what sides are given compared to that angle. What sides are given? 6 and 20, and what's a relationship with A?
Opposite and adjacent.
They are opposite and adjacent. So which trig function do I use?
Tangent.
Tangent. So I say the tangent of angle A equals 6 over 20. Okay, now you do not have to do a proportion because all of your numbers are on one side and your variables on the other. So here's what you do. This is how you do this. You push second, that little button, tangent, that button, 6 divided by 20 equals. And we do these to the nearest tenth. Angles are done to the nearest tenth. Angles are nearest tenth. 16.7 degrees. Do you agree? All right. Let me have you do this one, and then we'll get started. Okay? This is A, this is C, this is B. This is 15, and this is 3. I want to know angle A is what? Okay? All right, according to the sides, here's angle A. What am I given?
Adjacent and hypotenuse.
Adjacent and hypotenuse. Which trig function?
Cosine.
So cosine of angle A equals what?
3 over 15.
3 over 15. So I'm going to hit second, always second, cosine 3 divided by 15 to the nearest tenth. What do I get?
78.5.
78.5 degrees. Connor, do you understand that? Okay. Do we have any questions about that? All right, one last thing here. All right, we have what we call solve a right triangle. Solve a right triangle. Solve a right triangle means finding all the unknown parts. Okay? So what happens is I give you a right triangle. This is R, this is Q, it's the right angle, this is P. This is 16, and this is 33 degrees. Okay. So, what's unknown?
Hypotenuse.
Well,
Oh.
the hypotenuse is unknown, this leg is unknown, and this angle is unknown. All right, what would be the easiest to start with? The angle. Tell me why.
Subtract 190.
That's right. We just take, can I just take 90 minus 33? Because this is 90, so these two have to add up to 90, right? So 90 minus 33 is what? 57 degrees, is that right? Okay, now what I'm about to tell you applies. Could I have made a mistake on this? Yeah, it's not real possible. We have calculators, right?
Yeah.
But I caution students. I say, you know what? always go back to what they give you because you didn't make a mistake on that. That was given. So from now on, when I find these sides, I'm going to use this and this. I'm not going to use any information unless I have to of what I found. Because if I did a mistake, it's going to carry over to my next problem. Okay, so what I'm going to do is I'm going to find, let's find this side first, which is angle P, little p, right? Because it's across from P, correct? I'm not going to use angle P because I found angle P and I don't know if it's right. Probably is because I got a calculator. It's simple subtraction. But I'm going to use this. So I go to 33 and I look at P's relationship with 33. What is it? It's adjacent, and I have,
16.
which is
Opposite.
opposite. Which one refers to adjacent and opposite?
Tangent.
Tangent. So I say the tangent of 33 degrees, right, equals opposite, which is 16 over P. I put it over 1, correct? And I cross multiply. Here's one where I'm going to divide. So I have P times the tangent of 33 degrees equals 16. Is that correct?
Yes.
And now I divide both sides by tangent of 33 degrees. And I take 16 divided by, I get P equals 16 divided by the tangent of 33 degrees.
24.1, right?
What's that?
24.64.
24.64. It's a side, so we want 2, right? And there's no label, is that true?
Yes.
Okay. Did they switch? No, it says the nearest hundredth there. Did it switch on this one? Yeah. Now it says the nearest tenth. You gotta watch your directions. They're switching on us. Okay? Alright, now I don't want to use this unless I have to. So I go back here and I want to find Q. Q is this guy right here, right? It's across from, he's hypotenuse, right? So I want to go back to this 33, correct?
Mm-hmm.
And I have the opposite and the hypotenuse. What's the opposite and the hypotenuse?
Is that sine?
That's sine. Sine of 33 degrees equals 16 over Q. So once again I cross multiply and I have Q times the sine of 33 degrees equals 16. So I divide 16 divided by the sine of 33 degrees. Now you can, does anybody go, well, we just did that, right? Did anybody say that? Well, we just did that? No, we didn't, because we did tangent. So that's different. So Q to the nearest tenth is what? $29.4. That is correct. Do you agree? Tyra?
Yeah.
Okay. All right. All right. Let's take a look at the set of directions on page 601. Your assignment is page 601, numbers, and I'll have somebody write it up there when we're done. But 601, 16 through 20 even, and then 21 through 43, all. Okay? 16 through 21, it says, find the sine of J, the cosine of J, the tangent of J, the sine of L, cosine of L, and tangent. Guys, it says express as a fraction in lowest terms and as a decimal to the nearest hundredth. So you're going to, not only to write a fraction, you're going to do this right here. You're going to do this fraction right here. Remember this fraction? You're going to make sure it's simplified, then you're going to write it as a decimal. So you're going to take 8 divided by 15. Okay? And to the nearest hundredth. Okay? All right, and there's 3 of those. Then the next section says use special right triangles to write the decimal to the nearest hundredth. I want that as a radical and to the fraction. So we're going to look at right here. Remember the sine of 60? The sine of 60 and the cosine of 45? Only you're going to, not only you're going to write them as a fraction, but then you're going to change them to a decimal also. Okay, and it says to the nearest hundredth, okay? Then you're going to start solving them. And it says to the nearest tenth. So you're gonna start drawing the triangles, labeling them, choosing the right function, and then getting a decimal. Okay? And last, but certainly not least, is where you had it, it's solving a right triangle. So you're gonna solve all the parts. You're gonna do it to the nearest tenth and to the nearest degree. So if we didn't have an angle, we'd do it to the nearest degree. And remember, when we solve for an angle, we use inverse. Remember? Inverse, second, whatever. Okay? All right, this assignment is due Monday. If you're not going to be here Monday, no, it's due Tuesday. Turn it in before you go to music if you would, so we don't lose it. All right, any questions? All right.